Hi, I'm Mike Henderson. I'm a solution architect with Anaplan, and I'd like to demonstrate today a very different approach to data hubs. There's common wisdom says that you really shouldn't bring in detailed leaf level broad data sets into an Anaplan data hub. You really should be doing your filtering and summing, your aggregating in the source system before bringing it into the hub. So you should set up queries that are specific to the needs of a downstream spoke model. Well, I've got an approach that kind of flies in the face of that common wisdom. And well, the shocking thing is that with some thought, we're able to come up with a surprisingly small. This is a 0.14 gigabyte or 140 megabyte model here, which is going to allow us to do 7 dimensions: department, product, location, entity, account, scenario, version, and time. My if you were to take the product of all of the 36 months of time, quarters, years, times the number of departments, products, locations, entities, accounts, and scenario version members in this cube, you'd come up with a number like 3 trillion potential combinations of members. And well, if we were to dimensionalize by those dimensions, there's no way we could handle that. Anaplan has a limitation of 130 gigabytes for a workspace, and the 3 trillion member combination cells would blow well past that 130 gigabyte limit. So instead, we're going to use concatenated keys on both the input side and the output side, and we're going to do some clever mapping of input keys to output keys in order to radically compress, squeeze down the amount of RAM that is required in order to deliver the fully rolled up sets. So here we go. You can see that my input key is very typical for a concatenated key: department, product, location, entity, account, and scenario version are included in this 6 segment key. And then the seventh dimension is time. 36 periods of time are listed across here. My fact table, my data import that I generated for this proof of concept model is 12 megabytes. It is 38,000 rows times 36 columns. So that's a heck of a lot of data that's being brought in. Not terribly huge, but it's a good size. And you can see that my department hierarchies are brought in as parent-child keys with code and display name, the typical stuff that you'd see for department, product, location, entity, account, and scenario version. And in my demo model, I use some numbered lists, some composite hierarchies, some single list, ragged hierarchies. I tried to mix it up real good. Another concept that's going to be important to us here is when you look at the accounts dimension, and I treat accounts as a list here, you'll see that the accounts dimension includes an income statement and a balance sheet, and there's 300 or so leaf level accounts in my demo model here. So you can see these 10 accounts are in revenue, and we could drill into any of these, and we'd see it on that order of magnitude of leaf level accounts rolling up. But I want you to think about this: when gross margin, if we're going to report this as an output line, then gross margin would need to sum these revenue accounts and subtract the sum of these cost of goods sold accounts. Hold that in mind. I mean, the same thing is going to apply if we go up to operating income. It's going to take the sum of revenue accounts to subtract these. So we have to have a sense of which accounts, leaf accounts, roll up into which summary reporting lines by addition and which by subtraction. So in this particular proof of concept model, I have a mapping of account hierarchy to account flat list up here, where the account flat list is a potential output line, and the hierarchy here is the data is accounts that may be in a data key. And so if you, I'm going to scroll right here a little bit, and we're going to pick out my friend revenue, and you can see that revenue uses a multiplier of +1 for these input revenue accounts. Scrolling a little bit further to the right, we see that cost of goods sold, total COGS, uses plus for each of the cost of goods sold accounts, and that gross margin uses some pluses and some minuses. Okay, so we have this mapping table that allows us to discriminate between which ones add, which ones subtract, and which ones are irrelevant. You know, none of these expense accounts or what have you are at all relevant to gross margin. So they're all zeros, what have you. In my proof of concept model, you can see these cells are blue. So these are inputs. I could just as easily have calculated them as input them, what have you. In some data warehouses, you actually have this. You'll have the relationship between leaf account and roll-up line as a multiplier. So in this particular proof of concept, I've got it as an input, but I could just as easily look at the consolidation operators, the roll-up operators in the accounts hierarchy, and say and determine whether I need a +1, a -1, or a 0 in this table. Okay, now let's go to the query designer. Okay, the query designer is intended for, let's say you're a model builder building a spoke model, and you would come into this and you'd say, okay, I need a query number 1. All right, and for this particular, we're going to have a saved query that is going to be repetitively executed every time that we want to, load new data into our spoke model. So we need to save the query definition, and this is how we do it here. We configure the query here with a description. Oh, query 1 is pre-configured for us. It is major P&L lines for each entity and total entities. Oops, not each entity. Let's see, I need those and for it to be each entity. All right, it's going to look at the top of product, department, and location. So top of department, top of product, top of location, and it's going to get actual and budget final. So actual and budget final are checked, and the major P&L lines are revenue, cost of goods sold, gross margin, etc. So my model builder has come in here and checked what are the reporting lines that he wants, and once he's done that, this query is saved. He would then run the update all queries process. Now this is a sequence of steps that builds the output key, those intermediate add and subtract mapping keys, and populates the information into the output reports as necessary. So that's basically what it's doing. I'm not going to run this here, but this entire process takes about 60 seconds in my model. All right. So once that is done, we could go to see query 1 results, and here you can see a fully rolled up profit and loss statement for actual and for budget final, as requested at the top of department, product, and location and entity. Okay. All right, query 2 results. Query 2 is different. It's looking only at revenue and COGS accounts by product category and by region. These are roll-ups in the intermediate roll-ups in product and location, in the product and location hierarchies. Again, I'm going to go back over to my query designer. I'm going to look at query 2 here. Okay, revenue and COGS accounts by category and region. All right, so down here you can see that we have checked the revenue and COGS accounts that we're going to include. We're only using actuals in this one. We don't care about legal entity, so we're going to take the top of the house there. In my fictitious model here, as is common, the revenue and cost of goods sold are booked to a product line. And here we're choosing them at the product category level of the product hierarchy. Meanwhile, uh, their revenue and cost of goods sold are always booked to no department whatsoever. And so down here at the bottom, we have a null department, what have you, which allows us to go ahead and ignore that, but we have to specify something. So we've got these null members that are sitting down here at the bottom of department, product, location, etc. What have you. Our time filter is it's showing data only at the quarter level. And I may have chosen other filters, but for this particular downstream model, it just happens to need revenue and COGS at the quarter level. All right. Okay, with that query defined, we come in here and we see the results. So these are our detailed revenue and COGS. The A5s are our cost of goods sold accounts, actual, by location, region, and by product at the category level, what have you. And you can see that the time filter has been obeyed, that it is showing me only at the quarter level. Okay. Whoa, I've just fallen out of my model. Isn't that nice? In any case, that's our demo. Oh, the surprising thing here is that my model is a total of 136.9 megabytes. It's downright magical to me. But it really lifts the restriction that we have in our thinking about using large sparse data sets in Anaplan. I'd like to hear your feedback. Let me know what you think. Again, I'm michael.henderson@anaplan.com. I'd love to hear what you have to say. Thank you.